Good afternoon and welcome. My name is Chen, and today I'm going to talk about investigation on effect of wheel polygonal wheel on high-speed vehicle track subgrade interaction based on green function method. The presentation is structured as follows. Firstly, I will introduce the problem about wheel polygon occurred in high-speed railway, some research on its dynamic, and the motivation to develop a new method. Afterwards, the simulation model will be presented. I will then show simulation results and discussions. Finally, some conclusions will be drawn. So let's start with a brief review. Wheel polygonal wheel is a typical defect of the rounding surface of a railway wheel, which belongs to a circumferential radius variations of the wheel. It will give rise to noise, additional dynamics, and the material consuming of the wheels. As mentioned by Johnson, wheel polygonal wheel with a few dominating harmonics were detected especially in high-speed trees. The dominated harmonics are mainly first to fifth orders. For example, as shown in this figure, it is dominated by the third orders. With the in-depth development of China high-speed railway, higher order polygons have been found in high-speed tree. As shown in the figure, this is a wheel polygonal wheel with 250 km per hour. It is dominated by the 23 and 24 orders. Nowadays, wheel polygonal wheel is a common phenomenon. Many research on it have been carried out. Research on the mechanism of wheel polygon and its evolution tree have been carried out by many scholars. However, there is no definite conclusion about the origin and evolution tree. The influences of the wheel polygon on vehicle dynamics also have been researched, in which the track system is usually assumed to be a rigid base. It is defective to reflect the real responses under the excitation of mid and high frequencies. There is little literature taking non-balanced track and subgrade system into account, but it needs to be discussed. Therefore, a vehicle track subgrade interaction model should be considered. In the dynamics analysis of the vehicle track interaction, there are mainly two methods to construct track system. That is, model superposition method and finite element method. In the model superposition method, track model is truncated to a finite length, which will considerably reduce the calculation time, but the computational accuracy is affected both by the form of assumed mode and the number of truncated modes. The use of finite element method has advantages in describing track structure with a high complexity and nonlinearity, but it indicates high time-consuming and work nodes. Recently, the green function method has gained plenty of attention. In time domain, a green function indicates impulse response function, while in frequency domain, it indicates frequency response function. As the wheel and the track system can be represented by the pre-calculated green functions, so the model can be performed with high computational efficiency. But in most of previous studies, the structure under the wheel is always simplified, resulting in a deficiency in describing the high-frequency vibrations of track system. Moreover, the moving green function of the wheel is related to the running speed of the vehicle, giving rise to no universality. Therefore, an improved method will be introduced here. In this paper, dynamic results of vehicle track subgrade system caused by wheel polygonal wheel with high order will be investigated, and the relationship between the main parameters of polygon and the dynamic responses will be illustrated. We will now move to see the simulation model. First, A time domain model is used in order to describe the nonlinear real contact, and the vertical interaction is analyzed. The vehicle-track-subgrade system is divided into two subsystems, in which the vehicle real subsystem and the snap subgrade subsystem are coupled through fastener connection. Interactions between vehicle and real are characterized by real contact, and the interactions between the two subsystems are transferred through fastener forces. Based on the theory of vehicle-track couple dynamics, a vehicle is treated as a multi-rigid body dynamic model with 10 degrees of freedom, and a real is treated as a continuous balloon owner being discretely supported by real pants. The real vertical force is determined by nonlinear Hertz contact. The snap subgrade system is modeled as a three-dimensional finite element model. In order to obtain the green functions of this system, a typical double block non-balanced track is used, which consists of concrete snap, supporting layer, and subgrade, modeling as a solid element. The model is constructed as a one-fourth structure due to its symmetry properties. The unit impulse excitation is applied to the position marked by the red arrow. The measured real polygon and Chinese high-speed non-balanced track random irregularity are superimposed as the excitations between the surface of the wheel and the real. In order to investigate the relationship between the main parameters of real polygon and the dynamic responses, a simple harmonic model is used here. Now I will show the simulation results that I've obtained. Figure shows the accelerations of the wheel seat and the car body. Under the excitation of the measured real polygon, the wheel seat vibrates extremely. However, the car body vibrates in small amplitude. It is attributed to the vibration isolation effect of the primary and secondary suspension structures. Figure shows the responses of the real vertical force, both in time and frequency domain. It is indicated that the real dynamic interaction is obviously enhanced, and the frequencies dominated by high-frequency interactions are 591 Hz and 616 Hz, which are corresponding to the 23 and 24 orders under the running speed of 250 km per hour. Figure displays the real accelerations. It can be seen that the real acceleration caused by the measured real polygon shows a distinct increase. Figure displays the dynamic stress and displacement on the concrete snap and subgrade upper layer. It can be observed that the high-frequency real interaction has little effect on the snap subgrade system. In the description of the real polygon, main parameters are order number, wave depth, phase difference, and so on. This section investigates the dynamic responses caused by different order and wave depths. Figure shows the responses of the real vertical force, fastener force, dynamic stress, and displacement on the concrete snap, excited by simple harmonics with different order and wave depths. It can be seen that with the increase of the order and wave depths, the maximum values of the real vertical force and the fastener force increase significantly, but the dynamic stress and the displacement on the concrete snap are mainly affected by the no orders. Summarizing the studies in this paper, some conclusions are where polygonal wheel with high orders will induce high-frequency wheel-real interactions, intensifying the wheel and real vibrations but hardly affect the car-body accelerations. The wheel-real vertical force and fastener force are significantly exacerbated by the increased polygon order. Finally, the snap subgrade system are mainly affected by the low orders of polygon. That's all. Thanks for your kind attention.